Okay, so this is a replacement video for class, so I've jumped the gun a little bit, but here's chapter 9, firms costs, are really what we're going to be kind of primarily focusing on. So it's called firms and industries. It's going to set us up for thinking about different markets. But we have to understand the firm first. So a couple of this is like things that we've already talked about. So the first is, the difference in costs. So we've got explicit costs. These are things we said anything we hand money over for. So this is going to be payment to our workers, so labor costs, the raw materials, rental space of our building. These are kind of typical things we think about. Now, we also have implicit costs. This is going to be whatever we're not using our money on. What are we giving up, right? So this is going to be very similar to opportunity costs, right? So the opportunity cost of our time, what could our workers be doing? What could we be doing with our raw materials instead? So instead of building, if I have a factory, instead of, I don't know, 3D printing for one company, their product, I could be, making in other companies. So we're not just going to have kind of the opportunity cost of time now, or what I could have been doing with my time, but what could I have been doing with my raw materials, my money, my capital? I could have been investing this elsewhere. So our total costs are just going to be the sum of the two. So we're primarily going to just focus on total costs, but kind of behind the scenes, there's going to be both of these. So we're going to understand a little bit more about how opportunity costs, or these implicit costs, influence the firm. So we've already talked about opportunity costs before. So this is kind of the idea. I'm thinking about going to school for another year. I kind of looked up some of these values ahead of time. I think if you do like room and board at IU plus in-state tuition, I think it's like 30,000 a year. So if we just kind of assume 4 years to get your degree, your total kind of explicit costs, room and board, tuition, all these things you're handing money over for, it's gonna be about $120,000. That might be a wake-up call to some of you, right? Now, we can also think about, well, what is what's the benefit of that? Well, here's my cost. Like, I hope that I'm, earning a pretty good salary once I get out of here. But we can also think about, okay, maybe let's say after I get done, I think about I can make, I don't know, $70,000 a year, right? That's going to be kind of my starting salary, right? So if I think about like even the first 5 years, let's just say after I get out of college, what would I be earning? So I'd have what? $350,000 total. So I might look at this and say, well, look, this is an excellent investment, right? Even over those first 5 years after I graduate, what's that difference? Well, looks like I'm making $230, $30,000, almost like profit, right? For the individual. We'll eventually kind of think about the firm eventually, but just setting up opportunity costs this way. However, I can think about what were my implicit costs, right? What was I giving up? So even though I started working this job making 70,000, the 4 years I was at college plus those 5 years, I could have been maybe making, I don't know, um, working overtime, working at a job making $50,000 a year without a degree. So I can think about, well, what's my implicit cost over those 9 years? Well, it would actually be that I'm giving up making $450,000 somewhere else. So what is kind of my total profit as an individual? Well, I'd have to factor in those additional implicit costs, right? So my implicit costs here, the total was what? 450, which would have actually made kind of my total benefit over those 9 years, negative 220. Now, obviously, we could play around with these numbers a little bit. Maybe I can't make quite as much not working, this degree or this job that needed a degree. Maybe I make a little bit more over time. But this kind of just goes to show, like, if I make the decision not factoring in my implicit cost, it looks like clearly it was optimal to go get my college degree. If, depending on what my outside opportunities were, right, maybe it's not, right? So we want to be factoring in our explicit and our implicit costs when we're thinking about making decisions. The same goes for firms. Okay. So let's think about kind of the firm, right? I've kind of got all this set up here. You could make, think about your total costs or your explicit plus your implicit. I think here I had a little bit more exact numbers, right? So kind of maybe it was only 40,000 I can make elsewhere. And I could think about what was my total cost each year. Oops, sorry. I attended school, right? And I want to be factoring those in. So the firm's going to do the exact same thing, right? They're going to factor in not only their implicit, but their explicit costs, okay? So if we think about what a firm's main goal is, it's going to be to maximize not revenue, right, but profit. So what kind of profits are they going to maximize? So in general, when we think about profits, we have two different types. So one of them is kind of similar to the first setup that we had with thinking about the college degree, which is just factoring in my explicit costs. Those are going to be what we call accounting profits. All accounting profits are my total revenues I make from selling my product minus how much money did I hand over to produce it. Now, these are fine, and this is what we would kind of see like on the books, but we also need to factor in what could have we been doing with our money, right? This is the idea, if a firm could be investing into a production process and they invest, I don't know, $100,000 and they make 500,000. Well, that sounds great. Accounting profits are 400,000. But what if that same $100,000, if they would have invested it somewhere else, they could have made $1 million? Well, they're foregoing that. So that now becomes an opportunity cost. And they actually, by choosing to do what they're doing before, right? And they're making $400,000 of profit, but they were foregoing making another million. They're actually having negative profits. Now, the profits that I'm mentioning here that are negative would be economic profits, right? So you would take our total revenues minus not just the explicit, but also the implicit costs, these opportunity costs, okay? So our main goal when we're looking at firms is not to maximize accounting profits, but to maximize economic profits. So you can kind of think about like a little easy example, thinking about someone who's going to start like a small business. So maybe I want to open a restaurant in Bloomington, and I'm like, oh, I think there's an opportunity. The ones here I don't like as much, so I think that there's, room out there to kind of in the market. So I kind of look at this. I'm like, oh, well, I could make $500,000 if I open this restaurant. I've had to pay my workers. I've got to buy my food, rental cost of the building, maybe some machinery, ovens, things like that. So my accounting profits, if I add up all these costs, I'm looking like, oh, if I open this restaurant, I'm making $100,000 a year. That's a pretty good salary. The profit for the individual here, the profit for the firm, well, people run firms, right? Someone's owning this restaurant, so they're making $100,000 a year. However, what if they could have been working as a chef somewhere else? Well, then I'm foregoing working as a chef, making $150,000 somewhere else. So even though I was making $100,000, what was my total economic profits? I need to factor those in. Those were part of my economic costs. My economic profits would be the total revenue minus the explicit cost, but also that implicit cost of that wages I was foregoing by working as a professional chef. So maybe here, if I factor in those costs, it looks like my economic profit was actually negative. I was losing $50,000. I shouldn't start this restaurant, right? So therefore, don't run this restaurant, right? Because the economic profits were negative, right? If the economic profits were positive, then it would have made sense to do this, right? Think about, a different example where maybe owning the restaurant, I made $200,000. Well, now I'm foregoing working as a chef, making 150. What's my kind of total economic profit by running the restaurant? Positive 50,000. Well, then I should open it. I'd be better off if I was, running that restaurant as opposed to working as a professional chef. Okay. So we should choose to do something as long as the total revenue is greater than the total economic costs, right? Factoring in both those implicit, explicit costs. So I think here I had kind of a second example. Maybe I can't make as much as a chef, maybe only 50,000. But I also want to kind of give you an idea of some other implicit costs that can exist. So it's not just how much money I'm foregoing by not owning or running this business, but taking all the money that I was spending on, my labor, all these machines, the ovens, everything like that. If I had invested it into some mutual funds, maybe I could have made $10,000 over the year on that. So it's not just going to be my implicit cost of the wages I'm foregoing, but maybe interest, right? Or kind of gains here on these mutual funds that I could have made had I invested all of that money that I was using on these explicit costs. Now here, this is an example where I said, even if I factor these in, my total revenue minus my total explicit minus my total implicit cost, I'm still making $40,000 economic profit. I should run this restaurant, okay? So once again, we kind of talked about these before in the decision-making of the individual. Now we're just thinking about it in the context of a firm. So another type of cost we'll think about when we're talking about firms' costs are going to be sunk costs, okay? So a sunk cost is something that no matter what I do moving forward, whether I shut down my business, whether I continue to operate, doesn't matter how much I'm producing, these costs are going to be the same. Oops, I'm going the wrong direction. There we go. So Sunk costs should be ignored in decision making, because if they're going to be the same no matter what I do, my decision ultimately won't impact these costs. Now, when it comes to like my decision to own or start a restaurant or not, well, there, my labor costs, right? If I don't own the restaurant, I don't have to pay any workers. However, if I spend a bunch of money, I take out a loan and I'm locked into that loan, I've got to pay that loan payment no matter if I keep the business going or I shut it down. So this is the idea of sunk costs. Once again, I try not to use too many of these. Like I like to explain it in another way, but just to connect with some of those, some of those of you who might understand, be more familiar with these phrases. There's no use crying over spilled milk. It's already spilled, right? These sunk costs that we already have to pay them no matter what we do moving forward. So we should ignore them in our decision making. Okay. So let's think about an example. Once again, we'll kind of put this in an individual context, and we'll think about it more in terms of firms later on. So let's assume you want to go to a movie and it costs $10. Once again, I don't know. This is probably starting to get an age. Just trying to use a nice, easy number, but also no one goes to the movies. So anyways, let's say you're going to go, right? You look in your wallet and you realize, oh, well, I was going to go and it cost me $10, but I lost the $10 that I thought was in my wallet. Am I still going to go to the movie? Well, if I was going to make the decision to go before, I must have believed that the marginal benefit was greater than the marginal cost, right? So the additional benefit I was getting to go to the movie must have been above that additional cost of $10. Now, once I lost that $10, what's my marginal cost if I choose to still go to the movie? It's not 20, right? Because this is gone either way. So the change in my total cost, or that marginal cost, is still just the price of the ticket. So it still should be that the marginal benefit, if it was greater than that marginal cost of 10 before, it's still greater than the marginal cost of 10 now. So you can almost think about when we're making decisions, these sunk costs don't get factored in when we're looking at things on the margin. So you can kind of think about this in a different context. If I lose the ticket, right? So I spent $10, I lose the ticket, I have to go back and get another one if I want to go see the movie. Should I go back and get it? Well, that $10, if I lost the ticket, that $10 is gone no matter what. So if the marginal benefit was greater than 10 before, it's still greater than 10, I should still go back and get another ticket. Okay. So it's the same idea here when it comes to firms. If I have a huge loss this year, when I'm making my decision about whether or not I'm operating next year, as long as I think I'm accurately identifying the market conditions, the money I lost last year is gone. If I believe that staying open this year, I can generate positive economic profits, I should still stay open, because that loss is going to exist no matter if I continue to operate or shut down this current year. Okay. So what do we say to the guy of the sunk cost fallacy? Not today, right? We're not going to factor in these sunk costs into our decision. Okay. So, and this is primarily because we're doing things on the margin. So I'll kind of give you, that movie. So let's do the firm, right? So let's say in year one, I don't know, my total economic profits, my losses were $100,000, right? If I'm making the decision, do I stay open in year two, and the total revenues that I've projected are, I don't know, 500,000. My total cost this next year, this includes both implicit and explicit. Let's say it would be only 400,000. Well, notice if I choose not to open in year two, what would my losses be? Negative 100,000. If I choose to open, well, I'm going to make 100,000. I still have those losses from the previous year, but notice 0 is better than negative 100, right? So as long as we're making decisions on the margin, not using, we won't be using these sunk costs, right? As long as I'm looking at the additional revenues from each additional year, I shouldn't be factoring in those things that are going to be losses, because even if I choose not to operate, I've still got those losses on the books. Okay. All right. So that's the idea of sunk costs. So we'll kind of see this pop up with firms. Some other terminology that we'll use probably a little bit more in class Thursday than in this video are going to be the idea between long and short run costs. So in the long run, we say we can change everything. Everything is variable. I can fire workers. I can move to a new building. I can even switch the product I'm creating, in different industries. Like if, once again, in my 3D printer example, I can start producing, goods for somebody else, a different type of good. So all those things I can change in the long run, right? I'm not locked into leases, right? I can kind of switch to a new facility. Now, in the short run, there's going to be a lot of inputs that are locked in, right? So if I've got a 12-month lease, I've got to pay that lease no matter what, if I choose to move or I choose not to. So sometimes in the short run, there are going to be things specifically we think about, like capital, land, maybe some investments I've made where I've signed an agreement to pay this for the next X years or X months that we're locked into. These are what we're going to call fixed, right? In the short run, there's going to be certain things that are fixed. Usually our resources that we're putting towards capital and land, they might be fixed in the short run. Now, labor can be fixed. Like if I've got, an agreement with my, an annual salaried kind of worker, maybe I'm locked in for that year. But, a lot of industries, when I think about like even factory workers, I can hire and fire workers day to day, right? And so in the short run, even my factors of production like labor might be not fixed in the short run, but there will be some costs that are fixed. So that's the difference between the long and the short run. In the long run, everything's variable. In the short run, some things are fixed. Some things I can't change. Okay. So when we're thinking about these firms and what they're going to produce, we're going to have floating around behind the scenes a production function. So this is going to say, given whatever level of capital, land, labor I have, or raw materials, machinery, workers that I have, I'm going to get a certain level of output from how much I've invested into those different factors of production. Sorry, just turn my phone volume off here. So that is going to be our production function. Given these different inputs, here's the total product I'm going to get. Okay. So usually we would write this as, quantity, how much I'm getting of this product, is going to be some function of these different factors of production, right? Capital, labor, etc. So we can represent this with a table or graph, right? And we've kind of done this before, but we'll build on a little bit what we've done. So if I think about like I don't know, something maybe we can all relate to, thinking about going to like a restaurant like Chipotle. So the store owner has capital invested. They've got a building, location, so land. They've got these factors of production, and given the amount of money they've invested, they can get a certain amount of output. But also, I'm not going to get any output, even if I have all this capital, if I don't have any labor, right? I don't have any workers. So as I hire more workers, the same amount of capital, I can get more output, right? So here we're thinking about, in the short run, even though I might be locked into this agreement to kind of own this building and pay for this plot of land, right, where I have my restaurant, those things might be fixed in the short run, but I can always hire and fire workers. That's what's going to be variable. Or in the short run, that's the thing that's not fixed. Okay. So I've got just kind of hopefully some easy numbers here we'll think about. Let's say I've got different number of workers, and given my capital, as I hire more workers, I should be getting more output. Now, what worker am I going to hire first? The one that's going to be able to produce the highest number of burritos, if I'm thinking about my Chipotle example. Now, I know they have different products. We're just simplifying it here to one product. So if I don't hire any workers, how many can I produce? Well, I'm not aware of a machine that can produce the burritos themselves yet. So maybe one day, but right now, 0, right? If I don't have any workers. So the first worker I hire is going to be the one that I think is the best. I look at all my resume or all the applications, and I'm like, this person I think is going to be the best at doing this. So I hire that worker first. I get 1,000 burritos from that worker. And I don't know if this is over a week or a day, probably not a day. Let's say a week or a month, right? So I then think about, okay, if I want to get more than 1,000 burritos, well, that maxes out this worker's time and resources. So I've got to hire a second, right? And if I want more than 1,800, I got to hire a third and a fourth and a fifth. So this is going to be my production function. Varied levels of that factor of production, which was labor or my workers, is going to get me different levels of output. So anytime we're thinking about this relationship between putting more money or investing more or increasing that factor of production, here it was just number of workers, the production function is going to tell me I'm going to get a certain amount of output or a certain number of burritos from having that many workers in my building, in my restaurant. Now we'll notice what's happening to the slope of this production function. So this is going to be going to follow a lot of what we've talked about in this class. As I hire or as I spend more on something, what's happening to the marginal benefit? Or in this case, what is the benefit to the firm? What's the additional units? So every time I hire a worker, the change in the number of burritos or the output I'm getting from that worker, notice that slope is decreasing, or the additional burritos I get per worker is going down, right? You can kind of think about what does that represent? We're going to call that not the marginal benefit to the firm. We'll be a little more specific here, but since we're talking about labor, it's the marginal product of labor. All right, so every additional worker I hire, I'm getting a certain number of additional units of output, in this case, number of burritos. So anything on the margin is a change in something divided by a change in something else. So what are we kind of what we think about before? What was like marginal benefit was the change in the marginal benefit from the change in the number of units. Well, we're not buying more here. We're a firm. We're hiring more workers. So that's the initial change. So what is the change in output that we get as a result of changing the number of workers we have, or the change in output over the change in labor? So this is where it's a little bit different than anything that we've kind of calculated on the margin before, because usually quantity is in the denominator, right? And that's because we were quite often measuring marginal costs or benefits when we're thinking about how many units we're producing or how many units we're buying. Well, here it's how many additional units am I able to produce as I change this factor of production, which is labor. Okay, so labor is going to be kind of in our denominator. The output, or quantity, is going to be in our numerator. Okay. So if I go back to my example, what was that first worker? Hopefully, if I'm making my hiring decisions correct, the additional output I'm getting, or the marginal product of labor for that first worker, should be the highest, because I should be hiring the best worker first. And then as I hire the next best and the next best worker, the additional output I'm getting per worker is going to start to go down lower and lower as I'm hiring less and less efficient workers. Okay. So for this first worker, I kind of kept these changes in labor easy. It was just one. So if we go back to thinking about our marginal product of labor, the change in output divided by a change in labor, our change in labor was just one. The denominator being one kind of makes this easy. Okay. Let's make sure. Hold on, I'm panicking. Okay, my audio is going on. Gave me a little message there, but I'm pretty sure the audio is recording. So this first worker, what was the change in output? I was getting 1,000 additional burritos over that change in labor of one. So my marginal product of labor was 1,000. Now notice that second worker, the change in output was only 800, going from 1,000 to 1,800. And I was still increasing labor by one. So my marginal product of labor, 800 over one, 800. And then 600, 400, 200. Notice my marginal product of labor, as I hire more workers, is going down. This was the idea that that slope of my production function, the slope represents the marginal output, right? This function told me the total output, so its slope will tell me the marginal output from each worker. That slope is going down or decreasing. So if I wanted to kind of do this instead of jumps of one, just to kind of make this point that we can, notice, well, if I want those first 1,000 burritos in this example, I've now got to hire 10 workers. So if I hire 10 additional workers, what would my marginal product of labor be? Change in output of 1,000 divided by my change in labor of 10. So my marginal product of labor would be what? Only 100, 1,000 over 10. And then the second, going from 20, not the second worker, the second batch of 10 workers, going from 10 to 20, the change in the burritos, or my output I got, was 800 divided by the change in workers. I hired 10 more workers to get that. 800 over 10 would be 80. And then so on and so forth, right? So we still have that as I hire more workers in this example, doesn't matter if I'm doing, jumps of 1 or 10, maybe I look at the books and maybe it's not one individual Chipotle, it's, I don't know, I own 5 Chipotles in the area or something like that. We still have that my marginal product of labor is decreasing or diminishing. Okay. So if I was giving you an example, if we were in class, maybe one of the in-class quiz questions would be something like, what's the marginal product of the fifth worker here? Well, it's not the total output. It's the change that I'm getting from hiring that fifth worker. So when I'm going from the fourth to the fifth worker, what was the change in output? I was getting 11 additional bushels of wheat here, divided by, I'm hiring one more worker. So 11 over 1 would be 11 bushels. Okay. So nothing too crazy here. And now if we're going to put this in kind of graph form, I've already mentioned, we see this marginal productivity of labor decreasing. So if I, instead of plotting my output, I was to plot the number of workers and the marginal product of labor of each one of those workers, notice here's my total output function. The slope was just that marginal product of labor. So if I put that on a graph, oh, I thought I had them here. All I'd be doing is plotting those values. So I'll do that for us. This is where sometimes I forget when I'm not in class that I was going to do this in class. So if I think about kind of my quantity of labor or the number of workers I was hiring, so 1, 2, 3, 4, 5. The marginal product of labor, that first worker, I was getting 1,000. Second worker, I was getting 800. And then 600, 400, 200. So notice my marginal productivity of labor is decreasing. Okay. So I forgot to say it in the middle. So I'm going to splice this in so everyone's kind of watching. The number for the in-class quiz, we're not going to be in class on pi day, so I'll give you kind of the first 5 digits of pi, right? So 3.14159, that will be kind of the magic number to get the points for the in-class quiz for watching this video. Okay, so we've got the fact that as we hire more workers, that marginal productivity labor is decreasing, right? And what that was representing to us is that the slope of this output function, this production function, was decreasing. As we hire more workers, we're hiring less and less efficient workers, right? So this was the idea of like diminishing marginal product, or what we end up kind of more specifically calling the law of diminishing returns. As I hire more workers, right, I'm hiring less and less efficient workers. And so that marginal productivity labor should be decreasing. However, we have kind of a caveat to this, which is that if I think about my Chipotle example, if I only have one worker, and let's say I hired the best worker first, they have to take the order, kind of get the order going, build the burrito, then ring the person up, then go all the way back to the end, get the next order, build the burrito, ask the person what they want, check them out. They have to do everything. They're going to, oh, now I have to go in the back and kind of, I don't know, start trying to cook some of the meat. I'm going to be not that efficient, right? It's going to be hard to kind of run everything on my own. And so my marginal product is going to be relatively low. But as I hire a second worker, well, maybe now I have someone just cooking the food, and I have one person just taking the orders and building the burritos. And then as I hire a third, well, now I've got someone cooking the food. I've got one person taking the orders and ringing people up. I've got one person just building the burritos. I can have my workers specialize. So when my workers specialize, it allows each one to become more efficient at the job or increase their marginal productivity of labor. You can kind of think about this in the context even like a university. If they had me teaching every single subject, I wouldn't be able to produce like any students, any degree, high quality degree students. But every professor you have has specialized in their area and become fairly marginally productive at, improving the knowledge of students in that specific area, or at least that's the goal. All right. So as I hire more workers, each one can specialize on their own tasks, and we might actually get this initial portion of the marginal productivity labor curve that's not decreasing. So kind of what would that look like? So instead of just decreasing, here I'm going to switch colors because my black marker is dying. Let's say I'm thinking about graphing out this marginal productivity of labor, and I've got kind of my number of workers or the quantity of labor here on my x-axis. Well, maybe that first worker, yes, they were the most productive. They could, add a pretty good amount of additional output. Their marginal productivity labor was relatively high. But as I hire that second worker, they can now specialize on a task, become even more productive. The second worker They're not running the whole thing on their own. They're specializing in a certain task. So the marginal productivity of labor of the second worker might actually be a little bit higher than that first one because I'm getting these gains from specialization. So that can occur up to a point, right? So we would say here, this would be the portion of our marginal productivity of labor curve where we are seeing gains from specialization, or the marginal productivity of each worker or of our labor is increasing. Now, eventually over time, if you think about Chipotle, okay, I've got one person cooking the food, one person taking orders, one person starting the order, handing it off, the next person building the burrito, the next person ringing people up. Well, by the time I get a sixth or seventh worker, I don't have any more stations. They're just kind of standing around. I don't have any more specialization. I'm just hiring less and less efficient workers. So eventually we get to a point where that marginal productivity of labor curve starts to diminish again. And as soon as it starts to decrease, we're back on that diminishing returns portion, right? It's going to look similar to what we drew before, right? So initially, we might have the marginal productivity labor increase, gains from specialization. So in general, that's a good thing, right? Do I want to hire more workers when I'm in this range? More than likely, because I'm getting more. If I was willing to hire the first worker when they were this productive, well, then of course I want to hire these workers. They're even more productive because of this gains from specialization. So in the long run, we'll end up seeing where do we end up kind of these like equilibrium or optimal production points, usually somewhere over here, where once labor starts to diminish, now we're going to have a certain point where it diminishes so much that it doesn't make sense to hire any more workers. Okay. All right. So kind of have a nice little kind of synopsis of this in the slides. No, this is the idea of my Chipotle example, I guess, like too many cooks in the kitchen, right? You get too many cooks, eventually they can start specializing on their own tasks, or sorry, initially they can start specializing on their own tasks. Eventually we get to a point where they're just standing around, right? We see the marginal productivity of each worker kind of decreasing. Okay. So similar to this idea of marginal productivity of labor, but a little bit different, is we can calculate the average productivity of labor. So remember, marginal is the additional number of units we get from hiring a worker. The average product would be across all of our workers that we have hired, what's the average product we're getting? So instead of changes in total output and changes in the number of workers, we're just simply looking at, well, what is the total output we're getting? Divide that by the total number of workers we have, and that's how much we're getting on average per worker. Now we know the first worker, we might be getting more units of output than we are from the 10th, but on average, what are we getting? So what'll end up being true, and this kind of will play a role once we get to costs as well, but introducing the idea here, is that if the marginal product of labor is ever above our old average, well, our new average is going to be higher. Right? And if the marginal product of labor is ever below the old average, our new average is going to be lower. Right? Kind of think about it. If right now, on average, I'm getting 10 units per worker, I then hire another worker and then they can only produce 5 units. Well, my new average has to be lower. Okay. So I've got a little setup here, but maybe just like a very easy, I don't know, I shouldn't say easy, but like let's think about, let's go 0, 1. So this is going to be my quantity of labor. So let's think about output here, marginal product of labor. So let's say the first person, I don't know, I'm going to keep these numbers kind of easy. So let's say 10, or sorry, 20. Let's do 10, right? So my marginal product was 20. Sorry, this is what I wanted, right? Something like that. What would my average product of labor be here? Well, notice if my average product here was just 20 over 1, so 20. What's my average product here? Well, the marginal product is below the old average, so my new average should be a little bit lower, right? If I'm averaging it out across these two workers, I'm no longer going to be getting 20 units per worker. Now I'm only getting what? 30 over 2 or 15. So anytime that marginal product is below the old average, my new average is a little bit lower. I can think about another scenario. let's say I was, I don't know, different one where I was having 4, 5, and then let's say output I was getting was, let's keep this easy. So 50, and let's say my average product of labor here would be what? 12.5. Let's say I add this new worker and I don't know, they do, let's say, oh, I want it to be a nice easy number. Let's do 20, right? Sorry, the total output is 70. So their marginal productivity of labor is 20. Well, if their marginal product is above the old average, what's my new average, right? So if I figure out kind of what my new average is here, I'm going to be at what? 14, if I'm doing math in my head correct there. So notice when the marginal product of labor is above the old average, my new average is going to be a little bit higher. So we can look at this in a slightly different context. Like here. So I've got my total output, I've got my marginal productivity of labor, and I have my average, right? Average was just coming from taking the total output, dividing it by the total number of workers I have. So notice here, like 1800 over 2 gave me 900. 2400 over 3 gave me 800. So notice when the marginal productivity of labor is above the old average, my new average is going to be a little bit higher. But as soon as that marginal productivity of labor is below the old average, my new average is going to be a little bit lower. Okay. So what is this going to look like if I kind of superimpose these on each other? Something like this. Okay. So maybe I'll give you another visual of this to kind of help remember with some different colors. So let's say I've got my quantity of labor here. I've got my average productivity of labor. I try to draw this to scale, but it's a little bit off. So what's going to be true is it's supposed to be hitting at the maximum point of the average product, right? Because anytime my marginal productivity of labor is above the average productivity, my average productivity of labor is increasing. Anytime I have a marginal productivity of labor being below the average, what's happening to my average productivity of labor? It is decreasing. Okay. So we have this relationship that exists between the average productivity of labor and the marginal productivity of labor. We're going to have a very similar thing existing for costs, but I want to kind of introduce it here. Okay. Maybe making it easier ones. And can kind of, where do those intersect? Well, that marginal productivity of labor will intersect the average at its maximum point. So I tried to draw it to scale with my drawing. I'm not perfect, but you know. So let's go back to our Chipotle example, and we'll kind of work in all costs, not just my workers' costs, not my labor costs, but all costs. So suppose I own a Chipotle and I'm spending $1,000 on rent, and I've got $2,000. If I want to hire a worker, that's how much it's going to cost me. Okay. So if I want to increase my output, I've got to hire more workers. That's going to cost me more money. So if I think about in this example, what's the cost of the building? Well, it's always $1,000. Idea. It doesn't matter if I hire no workers, if I hire 5 workers, the cost of that building is always going to be $1,000 to me. Now, if I want to hire that first worker, how much money am I going to have to spend? We said $2,000. So I guess I did have this as monthly burritos they're producing. So notice if I hire 1 worker, my total cost of labor would be $2,000. If I hire 2 workers, each one's $2,000, so my total cost would be $4,000. How do I find my total costs? And here, this is not opportunity cost, or sorry, this isn't factoring my opportunity cost. We don't really have a separate column for that. But let's just think about we somehow baked that into this. So I've got my total costs, just adding up my building and my labor costs. That shouldn't be too bad, right? So here's 1,000, 3,000, 5,000, etc. So now I've got 2 different inputs. One of them was fixed in the short run. That was my cost of my building. The other one was variable in the short run. I can change the number of workers I hire. Here's my total costs to produce these different levels of output. Okay. So I've got the number of burritos and how much it's going to cost me to produce each one of those. Right? 1,000 burritos would cost me 3,000. I need one worker. 1,800 burritos would cost me 5,000 because I need two workers, etc. So if I look at this total cost curve, right, I can kind of look at, okay, it's upward sloping. So as I want to produce more burritos, now we're no longer looking at workers on my x-axis. This is our output. What's happening to my total costs as I want to produce more of my product? Well, if I want to produce more, my costs are going to go up. Not only are they going up, what would the slope of this curve represent? So if this is my total cost curve, just like when we had the total output from our workers, the slope of our total output from our workers was our marginal product of labor, or the number of additional units we were getting from hiring one more worker. Well, if this is the total costs from producing a certain number of burritos or a certain quantity, what would the slope of my total cost curve be? That would just be my marginal cost. Okay. So my marginal cost, we'll calculate it. We've done this before in the context of like individuals spending money. And we've thought about it with supply. We said it represented the marginal cost of firms, but how do we actually calculate that? Well, it's the change in the total cost of the firm from what? From a change in the number of output or the number of units that they're producing. Okay. So here, how would I calculate my marginal cost? Well, at each point, I'm just going to look at the change in my total cost divided by a change in quantity. So for the first 1,000 burritos, what would my marginal cost be? Well, the change in the number of burritos I'm producing is 1,000. The change in the total cost is 2,000. So change in total cost divided by the change in the number of burritos, right? I would have marginal cost of $2. Now, if I want to get the next level of output, 1,800 burritos, what's my marginal cost? Well, the total cost is changing by 2,000, but here I'm only getting 800, right? Additional burritos. So my marginal cost is 250, 2,000 over 800. And then I keep on going, 2,000 over 600, 2,000 over 400, 2,000 over 200. Okay. So notice what's happening to my marginal costs. When my marginal productivity of labor was decreasing, my marginal costs are increasing. So you can kind of think about why. If I'm hiring more workers and each worker costs me the same amount of money, if those workers are adding less and less in terms of the number of units, or they're less and less productive, I'm spending the same amount of money getting fewer units. So the additional costs kind of per unit are going to be higher. Okay. So the idea of diminishing marginal labor directly gives us these increasing marginal costs. I think when we were even back talking about the supply curve, I set this up saying the same kind of thing. Okay, I'm hiring less and less efficient workers, so it must be that to get the same number of units, I've got to hire more people to do it. That's another way of thinking about it. Okay. So I've got increasing marginal costs, right? As I produce more, those total costs are always going up, but they're going up at an increasing rate. Okay. So we have increasing marginal costs. This isn't, I'm breaking the mold here. We've already talked about this in the context of supply. So how is this going to influence the firm's profit maximization decision? Okay. Well, we now know something about kind of the cost of the firm. What about the additional revenue? So when we look at this firm's profits, we said it's going to be their total economic profits will be their total revenue minus their total costs, right? Both their explicit and implicit costs. But just like individuals, the firms make decisions on the margin. Okay. So we want to be comparing the marginal benefit to the firm to their marginal costs. Well, we just talked about how we calculate marginal costs. How are we going to calculate their marginal revenue? Well, if total revenue is price times quantity, okay, and here maybe some of these are a little mathematically minded, I can set it up this way. So if my total revenue is price times quantity, my marginal revenue, or the change in total revenue, would be change in total revenue from a change in quantity. What does that look like? A derivative in respect to the thing that we're choosing. So what would the change in total revenue be if I decided to change quantity? If I take a derivative of this, it's simply the price. So the marginal revenue of the firm, how much money are they making on each additional unit? That's simply going to be the price. And we'll eventually talk about if they're in a perfectly competitive market, where does this price come from? This is just the equilibrium price. So we now have their marginal revenue or the marginal benefit to the firm. They're going to compare that to their marginal costs. As long as the marginal revenue is greater than or equal to the marginal cost of that specific unit, then we're going to produce it. As soon as the marginal revenue of producing something is below the marginal cost, we're not going to produce it. Okay, so firms are going to make decisions the same way that we talked about individuals are. Okay. So, right, you can kind of think about if the marginal cost of hiring another worker is less than the marginal product, right, or the marginal kind of revenue we can make from the product they're producing, we're going to hire them. So that sets us up to then kind of think about what a firm's cost structure is going to look like. So firms will have not only variable costs, so this is kind of what we've been focusing on, the number of workers they're hiring. They're also going to have fixed costs. So this is like in our example, Chipotle, you had to spend $1,000 on rent for the building no matter what. So we're going to have fixed costs, we're going to have our variable costs, we're then going to have the sum of those two, which will represent our total costs. Okay. So we'll kind of build this out. Oops. I've kind of got an example. So my fixed costs, no matter how much I produce, are always the same amount of money. My variable costs, as I produce more, what should be happening to those? Well, if I want to produce more units, I'm going to have to hire more workers. So my variable cost should be going up. Right? Which, if my total costs are now the sum of those two, my total costs, so sorry, those are my variable costs. My total costs will be the sum of these two. How much higher will my total cost curve always be than my variable cost curve? Well, it's always going to be adding in those fixed costs, so it'll be a little bit higher. Right? The difference between my total and variable cost curve will just be those fixed costs. Okay. Now, here's where I think I'm going to jump the gun a little bit, but that's all right. We'll come back to, I don't want to, doing this a little bit out of order, but I think it makes sense here. So when we're thinking about averages, right? Let me see, where did I put that marker at? I set it over here. Yeah, I like this blue one. So if I'm thinking about my quantity or the number of units I'm producing now, what's going to be true about my average fixed costs? So my fixed costs, we said, are always going to be some constant value, right? In our example, that was like 100. So my average fixed cost will be these total fixed costs divided by how much I'm producing. So if this value is always the same, as I produce more, what's happening to my average total costs? They're just going to be decreasing. So we'll start out there. We're always going to have that as we produce more. It's like we're taking the same value and we're spreading it across more units. So our average fixed cost as we produce more is always going to be a little bit lower. Okay. So we'll go back. That was my average fixed cost. This in our example, right? It's just 100 divided by higher and higher quantities. I'm getting a decreasing average fixed cost. Now, another thing that we talked about was this idea of marginal cost. So if I take those same total cost values that we had here, just taking that column, the marginal cost will be the change in my total cost divided by a change in quantity. So here, this is what, 70 over 1, 50 over 1, etc. So what's happening for these first 3 units? The marginal cost is decreasing. So what is this a result of? Well, remember, if each worker is costing me the same amount of money, right? As I hire more workers, right? They're costing me the same. But initially, what can we have? Gains from specialization. So initially, the first 100 units, maybe I don't need to hire as many workers to get the next 100 because now I can have them specialize at their tasks. So we might have initially that marginal costs are decreasing. And the reason why is because we said for those first few units, maybe we are kind of getting this gains from specialization from our workers. So they're actually going to be lowering the additional costs that we have. Now, eventually, diminishing returns take over. And so as we kind of hire more and more workers, we want to get more and more output. We're spending the same amount of money per worker, but getting less output. So our marginal costs there are going to go up. Right? So our marginal cost curve is going to kind of look like this. I don't think I have it in here. Sorry. Like a Nike swoosh symbol, right? Initially, our marginal costs might be going down. We said here, this is going to be a result of the fact that our workers are becoming more productive because of specialization. So anytime we have marginal costs decreasing, so maybe this is a way to kind of think about this. I can superimpose this. So let's say, here's my marginal costs. Anytime, so we have gains from specialization if my marginal costs are decreasing. As soon as my marginal costs start increasing, we know there we've got our diminishing returns to labor taking over. Okay. So we can put these like on the same graph. All right. So then we have one more cost. Well, sorry, two more cost curves that we want to talk about. We already talked about the fixed. The other is going to be our average variable costs. So our average variable costs are initially, if we kind of think about how we calculate those, we'll take our variable cost divided by quantity. So 70 over 1, 120 over 2, 160 over 3, etc. Notice initially what's happening to my average variable costs. Initially, they are decreasing. Once again, this is because we have gains from specialization. So each additional unit has a slightly lower marginal cost initially. So our average costs are also going down. Now, once diminishing returns takes over, our average is going to then start to kind of creep back up. Right? So, sorry, that's not quite technical. Eventually, we'll start to creep back up. So our average variable costs kind of have this nice like U shape to them. Initially, as we produce more, our average variable costs are decreasing. And then there's a certain point where they're going to start increasing. So initially they're decreasing, they eventually start increasing. Now, if I think about my average total costs, what would that look like relative to the average variable? So without looking at the numbers here, what's going to end up being true is, so here's my average variable cost. We said it has this kind of nice U shape to it. And I'll end up reviewing this in a little bit. But the marginal cost is going to hit that average variable at its minimum point. It's the same idea of when we were looking at the marginal and average product of labor. The same thing will be true about average and marginal costs. But if I'm interested in the average total cost, well, remember, it would just be the average variable plus the average fixed. So notice if my average total is the average variable plus the average fixed, my average total cost curve will always be higher than my average variable costs. Oops, sorry. My average total cost curve will always be higher than my average variable cost, right? Because it includes the average variable plus some additional amount. Now, what's true about my average fixed costs? Initially, they're really high. So initially, the gap in between my average total and my average variable cost is going to be relatively high. By the time I get out to here, what's going to be true about my average total and my average variable? They're a lot closer. So our average total cost curve will still have this kind of U shape to it, but the gap in between the average total and the average variable is going to be getting smaller and smaller because that gap is simply the average fixed costs, and our fixed costs are getting lower and lower. Now, what will also end up being true we'll talk more about this later on, is that it also intersects the marginal cost curve, or the marginal cost curve intersects it at its minimum point. Okay. So this is going to be the general cost structure of our firm. The average variable have this kind of U shape to them. The gap in between those two is getting smaller and smaller, and that's because the gap simply is the average fixed, and the average fixed is getting lower. And then our marginal cost may initially have this kind of decrease because of gains from specialization. Eventually, though, diminishing returns takes over, our marginal costs increase, hitting both the average total and average fixed at their minimum point. So I know that's a lot going on one graph, but this will be our firm's cost structure. Okay. And we can kind of see this play out with the numbers. If I look at my average total costs, how do I find those? I just take total divided by quantity. Excuse me. So 100 over 7 is 170, 220 over 2 is 110, et cetera, et cetera. So I get this kind of nice kind of U shape as well. So notice here, what was true about my average fixed? They were always decreasing. So notice the difference between my average variable and my average total initially was 100, then it was only 50, then it was 33.3. So that difference between the two, they're getting closer and closer together, right? 170 and 70 here. By the time I get down here, 88 and 74. So we'll have this nice U-shaped average total cost curve. The average variable will also be U-shaped, and the difference between those two is getting smaller and smaller. That was a result of the fact that our average fixeds are getting lower and lower. And then we said we had this marginal cost curve, which will intersect both of them at their minimum point. So marginal cost, this is the slide that I put in, always going to have this like Nike swoosh symbol. So this is our kind of firm's cost structure. Here's kind of the various equations that we kind of used throughout the entire discussion. So every time you want an average, so average total, just take the total cost over quantity. Average fixed, total fixed cost over quantity. Average variable, total variable cost over quantity. The total costs are the sum of our fixed and our variable costs. And then the marginal cost is the change in total over change in quantity. So one thing I didn't quite go over, but I'll kind of give a little bit of insight here as to why that is. So the way in which we defined our total cost was that was our total variable plus our total fixed. So if I just divide everything in this equation by the same thing, I'm not changing the equality. Well, what is my total cost over quantity? Average total. What is total variable cost over quantity? Average variable. What is total fixed cost over quantity? Average fixed. So that's why that equation holds as well. The fact that we define our total cost as the sum of our variable and our fixed costs really is synonymous with saying that the average total is the same as our average fixed plus our average variable. Okay. All right. So these are kind of our cost equations. I think what I'll start out with on Thursday's class is kind of filling out this table so we get a little bit of review of what was in this video. So we'll kind of do this on Thursday's class. So we'll end the video here. I may have like input somewhere in here, kind of what the magic number for the day is. There'll be a little in-class quiz to make sure you're watching this video. But otherwise, we'll kind of pick up on everything where we left off here on Thursday's class.